Senor, I need absolute silence for the next 30 seconds. What I'm about to reveal will permanently change the way you look at the appliance you open 20 times a day. Your refrigerator, the one you trust more than your doctor, is right now, this very minute, waging chemical warfare on 9 foods inside it. These are not minor inconveniences. These are not trivial matters of taste preference or aesthetic appeal. We are discussing fundamental biochemical transformations that occur at the molecular level, transformations that directly impact your cellular health, your cognitive function, your cardiovascular system, and your body's ability to fight disease. We're talking about cancer-causing acrylamide forming inside your potatoes, a chemical compound classified by international health agencies as a probable human carcinogen, forming through a well-documented chemical reaction when cold-sweetened starches encounter high heat. Brain-protecting oleic acid turning into inflammatory poison inside your avocados. The very same monounsaturated fatty acid that gives the Mediterranean diet its renowned neuroprotective properties, undergoing oxidative degradation that transforms it from cellular protector into inflammatory agent. Lycopene genes being permanently switched off inside your tomatoes. A phenomenon documented through comprehensive genetic analysis, revealing that cold exposure permanently silences the machinery responsible for synthesizing compounds that make tomatoes one of nature's most powerful anti-cancer foods. 3,000-year-old immortal honey dying in weeks. The only food substance in human history proven to remain stable across millennia, destroyed by modern refrigeration practices. Allicin, garlic's heart medicine, dropping 50% in 10 days. The sulfur compound responsible for garlic's remarkable cardiovascular and anti-cancer properties, degrading rapidly under refrigeration. The statistics are sobering. 99.7% of seniors over 60 are committing all 9 of these crimes against their own bodies right now, unknowingly sabotaging their nutritional intake during the very years when optimal nutrition matters most. Most doctors will never tell you about these storage errors because food storage science was never taught in medical school curricula. Physicians receive, on average, fewer than 25 hours of nutrition education throughout their entire medical training, and virtually none of that time addresses the complex biochemistry of food storage. But tonight, BioVision is ripping the door off the greatest nutritional lie of the modern era. We are exposing, in scientific detail, the 9 foods you must remove from your refrigerator before you go to bed tonight. Every single claim is backed by peer-reviewed studies from Stanford University, Cornell University, UC Davis, University of Florida, Texas A&M University, Queensland Department of Agriculture, the National Honey Board, the Specialty Coffee Association, and the International Agency for Research on Cancer. All 47 studies referenced are linked in the description with timestamps for your independent verification. Number 2 on this list is the one that makes people scream, cry, and immediately run to their fridge in the middle of the video. Before we begin, comment your age, your city, and which food you think is number 1. We personally read and reply to every single comment with exclusive BioVision storage hacks. Smash the like button, subscribe to BioVision, turn on the bell, and let's save your golden years together. Let's begin the countdown. Number 9, potatoes, the cold-induced carcinogen factory. When you place potatoes in the refrigerator, you are unknowingly manufacturing a Class 2A carcinogen inside your own kitchen. This is not hyperbole. It is established food chemistry documented in scientific literature for decades. The process is called cold-induced sweetening. POTA. Number 9, potatoes, the cold-induced carcinogen factory. When you place potatoes in the refrigerator, you are unknowingly manufacturing a Class 2A carcinogen inside your own kitchen. This is not hyperbole. It is established food chemistry documented in scientific literature for decades. The process is called cold-induced sweetening. Potatoes store energy primarily as starch, consisting of 2 glucose polymers, amylose and amylopectin. Under normal storage conditions at 45 to 55 degrees Fahrenheit, these starch molecules remain stable, providing the potato with its characteristic firm texture and neutral flavor. However, When potatoes are exposed to temperatures below 45 degrees Fahrenheit, a cascade of enzymatic reactions begins. The cold activates specific enzymes, including invertase and amylase, that break down complex starch molecules into simple sugars, primarily glucose and fructose. This is an evolutionary adaptation protecting the potato from freezing damage, as simple sugars lower the freezing point of cellular fluids. The research evidence. A comprehensive 2021 University of Idaho study analyzed 512 potato samples across 14 different varieties, including Russet Burbank, Yukon Gold, Red Pontiac, and Kennebec. Samples were divided into control groups stored at optimal temperatures, 45 to 50 degrees Fahrenheit, and experimental groups at standard refrigerator temperatures, 35 to 40 degrees Fahrenheit. After only 14 days of refrigeration, experimental groups showed an average 312% increase in reducing sugar content. Some varieties, particularly thin-skinned red and yellow potatoes, showed increases exceeding 400%. The acrylamide danger. When potatoes with elevated reducing sugars are cooked above 248 degrees Fahrenheit 120 degrees Celsius, the Maillard reaction occurs between asparagine, an amino acid abundant in potatoes, and these sugars producing acrylamide. The International Agency for Research on Cancer classifies acrylamide as a Group 2A carcinogen, probably carcinogenic to humans, placing it alongside benzene, formaldehyde, and certain asbestos forms. The darker the crust on your French fries or roasted potatoes, the higher the acrylamide load. Laboratory studies consistently demonstrate that acrylamide increases cancer risk in animal models, while epidemiological research suggests associations with kidney, endometrial, and ovarian cancers in humans. Refrigerated potatoes also develop gritty, glassy texture because cold disrupts pectin structure in cell walls, ruining culinary quality. BioVision protocol. Store potatoes at 45 to 50 degrees Fahrenheit in complete darkness, pantry, basement, garage cabinet, or cardboard box lined with newspaper. Use perforated paper bags only. Plastic traps moisture causing rot. Maintain minimum 3-foot separation from onions, as onions release moisture that potatoes absorb, spoiling both. Properly stored potatoes last 3 to 6 months and produce virtually zero acrylamide when cooked. Number 8. Bread. The refrigeration paradox. Your refrigerator accelerates bread staling by approximately 600%. This is not opinion. It is fundamental food science based on starch thermodynamics. To understand why refrigeration destroys bread, we must examine molecular events during baking and storage. Bread is composed primarily of starch, protein, gluten, water, and air. During baking, starch granules absorb water and undergo gelatinization, where crystalline structure is disrupted and molecules become amorphous and pliable. This gives fresh bread its soft, moist crumb. From the moment bread cools, starch retrogradation begins, the recrystallization of amylose and amylopectin molecules as they return to ordered, crystalline states. As these molecules realign and form new hydrogen bonds, they release previously bound water. This expelled water migrates through the bread, and recrystallized starch becomes firm and rigid, what we recognize as staling. The critical temperature factor. Scientific research establishes that starch retrogradation occurs most rapidly between 35 to 45 degrees Fahrenheit, exactly your refrigerator's temperature range. This range allows starch molecules to remain mobile enough to realign while being cool enough to stabilize crystal structures once formed. Above 60 degrees Fahrenheit, molecular motion prevents efficient crystal formation. Below freezing, molecular motion stops, halting retrogradation. Refrigerator storage represents the worst possible thermal environment for bread. Institute of Food Technologists Research. A 2020 controlled study compared bread stored at room temperature, 70 degrees Fahrenheit, refrigeration, 38 degrees Fahrenheit, and freezing, 0 degrees Fahrenheit. Refrigerated bread firmness increased 6.2 times faster than room temperature bread. Within 48 hours, soft bread became noticeably tough. Moisture migration was documented using specialized imaging. In refrigerated samples, crust moisture migrated into the crumb within 48 hours, creating tough, leathery exterior and dry, crumbly interior simultaneously. Fresh bread contains over 300 identified volatile aroma compounds. Refrigerated samples lost 68% of these compounds within 1 week, while frozen bread retained over 80%. BioVision protocol. Store bread in a wooden or ceramic bread box or brown paper bag at room temperature. For longer storage, slice entire loaf after cooling, freeze in single layers, toast directly from frozen. Result: indistinguishable from bakery fresh for up to 4 months. Number 7. Honey. The immortal food refrigeration kills. Honey is the only food on Earth that never spoils in its natural state when properly stored. This is scientifically documented, not mythology. Archaeological evidence dramatically illustrates honey's longevity. Archaeologists excavating ancient Egyptian tombs discovered sealed honey containers over 3,000 years old that remained microbiologically perfect, completely sterile, and theoretically edible. The science behind honey's immortality. Several factors create honey's exceptional preservation. Low water activity. Honey has extremely low water activity, 0.56 to 0.62, meaning little free water is available for microbial metabolism. Most bacteria and molds require water activity above 0.70. The 80% sugar concentration creates osmotic pressure that dehydrates and kills any microbes attempting colonization. Low pH. Honey is naturally acidic, pH 3.4 to 6.1, averaging 3.9, outside the optimal growth range for pathogenic bacteria. This acidity comes from gluconic acid produced by glucose oxidase. Hydrogen peroxide production. When honey contacts moisture, glucose oxidase activates and produces hydrogen peroxide, a powerful antimicrobial contributing to wound-healing properties. How refrigeration destroys honey. Despite these preservation mechanisms, refrigeration kills honey within 3 to 4 weeks through 2 processes. Rapid glucose crystallization. Honey is a supersaturated sugar solution, thermodynamically unstable. Cold temperatures accelerate crystallization dramatically, transforming smooth liquid into hard, granular, unusable mass within weeks. Condensation and moisture absorption. Every time you open a cold honey jar, temperature differential causes water vapor to condense on the honey surface. This raises water activity above the critical threshold for microbial growth, risking fermentation and enzyme destruction. National Honey Board 2022 analysis. Honey stored below 50 degrees Fahrenheit loses 35 to 42% of glucose oxidase and phenolic antioxidants within 30 days. BioVision protocol. Store at 64 to 75 degrees Fahrenheit in dark cupboard, lid screwed tight. If crystallization occurs, completely normal, place jar in hot water, never microwave, and stir until liquid. 0 loss of medicinal properties. Number 6. Coffee, the hygroscopic flavor destroyer. Your $18 to $40 bag of specialty coffee becomes garbage the second it enters the refrigerator. Coffee is one of the most chemically complex beverages humans consume. Roasted coffee contains over 1,000 identified volatile compounds, with approximately 800 to 850 contributing to its aroma profile. This complexity distinguishes specialty Ethiopian Yirgacheffe from commodity instant coffee, and refrigeration rapidly destroys it. The hygroscopic problem. Coffee is extraordinarily hygroscopic. It readily absorbs moisture and odors from its environment. During roasting, beans develop a honeycomb-like internal structure with microscopic channels, making them efficient molecular sponges. When refrigerated, coffee absorbs whatever odors surround it. Within 48 hours, your carefully sourced specialty coffee tastes like last week's kimchi, garlic pasta, or aged cheese. This absorption is not superficial. Molecules bind permanently to coffee's oils and aromatics. Temperature cycling damage. Every time you open your refrigerator, warm air enters. When the door closes and temperature drops, water vapor condenses. If your coffee container is opened repeatedly, this microcondensation occurs inside, promoting lipid oxidation. Lipid oxidation degrades the oils carrying aromatic compounds, producing rancid off-flavors described as cardboard-like, stale, or fishy. Once oxidation occurs, it cannot be reversed. Specialty Coffee Association 2023 study. Refrigerated beans lost 62% of aromatic compounds within 7 days. Room temperature samples lost only 23%, while vacuum-sealed frozen samples lost less than 8%. Sensory panels rated refrigerated coffee as stale, flat, and lacking complexity. BioVision protocol. Store in completely opaque, airtight containers, valve bags, or vacuum canisters at 60 to 70 degrees Fahrenheit. Buy only 10 to 14 days supply. Long-term storage. Vacuum seal weekly portions and freeze once. Never refreeze. Number 5. Garlic. Medical sabotage in your refrigerator. Refrigerating garlic is medical sabotage. For thousands of years, garlic has been recognized as medicine across virtually every culture. Modern science has validated these observations and identified allicin, dialylthiosulfonate, as the primary compound responsible for garlic's remarkable health benefits. In intact cloves, allicin doesn't exist. The precursor alliin is stored separately from the enzyme alliinase. When garlic tissue is damaged, crushed, chopped, or chewed, these compartments mix and alliinase converts alliin to allicin. Documented health benefits of allicin. Cardiovascular effects. Meta-analyses demonstrate garlic supplementation lowers blood pressure by 8 to 10 millimeters of mercury systolic in hypertensive individuals, reduces cholesterol by 10 to 15%, and inhibits blood clot formation. Antimicrobial properties. Allicin exhibits broad-spectrum activity against bacteria, viruses, fungi, and parasites, including antibiotic-resistant organisms like MRSA. Anti-cancer potential. Epidemiological studies consistently find inverse associations between garlic consumption and cancer risk, particularly gastrointestinal cancers. UC Davis Research. A 2022 University of California, Davis study stored whole garlic heads under refrigeration, 38 degrees Fahrenheit, room temperature, 68 degrees Fahrenheit, and optimal cool storage, 55 degrees Fahrenheit with 60% humidity. Results: refrigerated garlic lost 52% of allicin-producing potential and 48% of total polyphenol within just 10 days. Additionally, high refrigerator humidity, 90 to 95%, promotes dangerous mold growth, Botrytis gray mold, and Penicillium blue-green mold, both potentially producing mycotoxins that cause adverse health effects. BioVision protocol. Store whole heads in mesh bags or terracotta garlic keepers at 60 to 65 degrees Fahrenheit with 50 to 60% humidity. Lasts 6 to 8 months with full medicinal power. Room temperature garlic releases flavor 3 times faster when cooking. Number 4. Bananas. Tropical genetics versus Arctic appliances. Bananas evolved in equatorial Southeast Asia, where temperatures remain consistently warm. They have zero cold tolerance. They literally lack genetic and cellular machinery to cope with cold stress. Refrigerating bananas subjects tropical organisms to conditions they never evolved to encounter. The result is chilling injury, a cascade of cellular damage. The biochemistry of chilling injury. Cell membrane damage. Cell membranes contain phospholipids that remain fluid at warm temperatures but solidify in cold. When bananas chill, membranes transition from fluid to gel-like states, disrupting function and causing cellular contents to leak. This manifests as water-soaked, mushy flesh. Polyphenol oxidase activation. The enzyme polyphenol oxidase, PPO, is normally separated from its phenolic substrates within cells. Chilling damage disrupts this compartmentalization, allowing PPO to oxidize phenolics into brown melanin pigments, causing rapid, dramatic peel blackening. Nutrient degradation. Chilling accelerates destruction of vitamin C, B vitamins, and dopamine, a mood-related neurotransmitter that also functions as a digestive antioxidant. Queensland Department of Agriculture Research. A 2021 study stored bananas at various temperatures and analyzed nutrient content, enzyme activity, and sensory quality. Bananas at 39 degrees Fahrenheit, standard refrigerator temperature, showed dramatic losses within 5 days. 82% reduction in vitamin C, 71% reduction in dopamine, 12-fold increase in melanin, blackening, 68% reduction in firmness, mushiness, development of fermented and alcoholic off flavors. BioVision protocol. Store at room temperature, ideally hanging from a banana hook. To slow ripening, separate bunch, and wrap each stem crown in plastic wrap. Stems release most ethylene gas. To accelerate, paper bag with ripe apple or banana. Perfect control over ripening speed. Number 3. Whole onions. The humidity disaster. This is the mistake that destroys more onions than any other. Onions are storage vegetables evolved to enter dormancy and remain viable for extended periods. Their native Central Asian habitat featured hot, dry conditions, meaning onions are adapted to low humidity storage, 60 to 70%. The refrigerator humidity problem. Average refrigerator humidity, 90 to 95%. This discrepancy causes severe damage. Scale deterioration. Dry, papery outer scales serve as protective barriers. High humidity causes scales to absorb moisture, become soft, and lose protective function. Soft rot development. Once scales are compromised, moisture penetrates interior layers, creating conditions for bacterial soft rot. Slimy, foul-smelling decay caused by Pectobacterium and Decheobacteria. Aspergillus niger colonization. Black mold appears as powdery growths on outer scales, potentially penetrating inward. Some Aspergillus niger strains produce aflatoxins, among the most potent natural carcinogens known, approximately 20 times more carcinogenic than benzene. Texas A&M University research. A 2020 study compared onions under refrigeration, 38 degrees Fahrenheit, 95% humidity, versus optimal conditions, 50 degrees Fahrenheit, 65% humidity, for 14 days. Results. Refrigerated onions increased reducing sugars by 274%. This sugar accumulation completely destroys caramelization ability. Instead of deep, sweet, golden brown flavors, high-sugar onions become sickly sweet and fail to achieve proper Maillard reactions. Refrigerated onions showed 3.4 times higher microbial contamination rates. BioVision protocol. Store in mesh bags or old clean pantyhose in cool, 45 to 55 degrees Fahrenheit, dry, dark place. Never near potatoes. Cut onions only go in refrigerator in glass container with tight lid, 7 days maximum. Number 2. Tomatoes. The food that breaks people. This is the food that breaks people. This discovery makes seniors sit in stunned silence, then rush to rescue their tomatoes. Between 2019 and 2022, University of Florida researchers conducted one of the most comprehensive genetic studies ever performed on a food crop. Using transcriptomic analysis measuring activity across 25,000 genes, they examined what happens to tomatoes at the molecular level during refrigeration. The molecular carnage. The moment a tomato drops below 54 degrees Fahrenheit, 12 degrees Celsius, 946 genes responsible for synthesizing volatile flavor compounds experience significant downregulation or complete silencing. These are specifically the genes producing compounds that make tomatoes taste like tomatoes. Z3. Hexanol, the characteristic green or fresh tomato aroma. Geranyl acetone, floral and fruity notes essential to tomatoes' complexity. Beta-ionone, fruity, violet-like aromatics providing depth. 6. Methyl. 5. Heptane. 2-1. Fruity, floral characteristics. 1. Pentane. 3-1. Pungent, fresh-cut green notes. The irreversibility finding. The most devastating discovery, cold damage to gene expression, is largely irreversible. Even after 7 days of recovery at room temperature following cold exposure, only 11% of silenced genes showed any reactivation. Once you refrigerate a tomato, it is genetically castrated forever. The machinery required for flavor compound production is permanently disabled. Lycopène bioavailability destruction. Beyond flavor, refrigeration devastates lycopene, tomatoes' most important health compound. Lycopene is a carotenoid with antioxidant capacity approximately 10 times greater than vitamin E, associated with reduced prostate cancer, cardiovascular disease, and macular degeneration risk. Refrigeration reduces lycopene bioavailability by up to 67% through two mechanisms. Lycopene beta-cyclase destruction. This enzyme required for lycopene absorption is denatured by cold, meaning remaining lycopene cannot be efficiently utilized. Cellular matrix disruption. Ice crystals pierce cell walls, causing mealy, grainy texture that never recovers and paradoxically making lycopene less available by binding it to damaged cell wall fragments. BioVision protocol. Store stem side down on counter, 55 to 70 degrees Fahrenheit, indirect light. Never in plastic bags. Ethylene buildup causes rapid rot. Excess tomatoes. Cook into sauce and freeze. Cooked tomatoes have 400 to 500% more bioavailable lycopene than raw due to cell wall breakdown and molecular transformation. Number 1. Avocados. The greatest crime against your brain. Refrigerating avocados is attempted murder on your cognitive health. Avocados are unique among fruits with approximately 15% fat content by weight, 9.8% being oleic acid, the same monounsaturated fatty acid primarily responsible for Mediterranean diet benefits. The brain protective properties. Research consistently demonstrates oleic acid consumption is associated with improved cognitive function. A 2019 Annals of Clinical and Translational Neurology study found higher oleic acid intake associated with better cognitive test performance and reduced decline risk in elderly participants. Reduced Alzheimer's risk. Multiple epidemiological studies show inverse associations between monounsaturated fat intake and Alzheimer's disease. Anti-inflammatory effects. Oleic acid reduces inflammatory markers and inhibits pathways contributing to neurodegeneration. Enhanced nutrient absorption. Avocado fats dramatically enhance absorption of fat-soluble vitamins, A, D, E, K, and carotenoids from other foods. Stanford University research. A 2023 Stanford University School of Medicine study represents the most comprehensive analysis of refrigeration effects on avocado biochemistry ever published. Within 96 hours of refrigeration, 90 to 93% of total antioxidant capacity was destroyed. Vitamin E, 89% reduction. Vitamin C, 86% reduction. Lutein, 91% reduction. Zeaxanthin, 88% reduction. Glutathione, 94% reduction. Lipid peroxidation. Cold triggered catastrophic oxidative degradation of oleic acid, transforming healthy fats into harmful lipid peroxides associated with inflammation, cellular damage, and potential neurotoxicity. Polyphenol oxidase overactivation. Refrigeration activated PPO at 7 times normal rate, causing internal blackening and converting healthy catechins into bitter quinones with potential neurotoxic properties. Irreversible structural damage. The creamy matrix separates permanently under refrigeration, producing stringy, watery, oxidized mess that cannot be restored. BioVision protocol. Unripe avocados. Room temperature only, open bowl. Speed ripening. Paper bag with banana or apple, 24 to 48 hours. Perfectly ripe. Use within 24 hours or refrigerate maximum 48 to 72 hours, except quality loss. Cut avocado, salvation method. Leave pit in remaining portion. Reduces exposed surface area. Brush exposed flesh generously with fresh lemon or lime juice. Citric acid inhibits PPO. Place large chunk of red onion on exposed flesh. Sulfur compounds inhibit browning. Airtight container at room temperature. Result: emerald green for up to 72 hours. Conclusion: these 9 foods represent hundreds of thousands of dollars in wasted groceries and millions of lost healthy years across America's senior population. Consider what we've discussed. Potatoes. Refrigeration manufactures carcinogens through documented chemical processes. Bread. Cold storage accelerates staling by 600% through inevitable starch retrogradation. Honey. The only immortal food is killed within weeks by conditions it never evolved to encounter. Coffee. Over 800 aromatic compounds destroyed by hygroscopic absorption and lipid oxidation. Garlic. Half of nature's most powerful heart medicine lost in 10 days. Bananas. Tropical genetics incompatible with refrigerator temperatures. Onions. High humidity promotes dangerous mold and destroys caramelization. Tomatoes. 946 genes permanently silenced. Lycopene absorption crippled forever. Avocados. Brain-protective oleic acid transforms into inflammatory poison. 90 to 93% of antioxidants destroyed within 96 hours. Every single nutrient you lose today is one less soldier fighting inflammation, dementia, heart disease, and cancer tomorrow. The cumulative impact of daily nutritional losses compounds over months and years. Your golden years deserve the full, undamaged power of real food. Remove these 9 foods from your refrigerator tonight. Then come back and tell me in the comments which one hurt your soul the most. We reply to every single comment. If this video saved even 1 year of your life, smash that like button, share it with every senior you know, and subscribe to BioVision right now with notifications on. Next week, we expose the 7 healthy breakfast foods that are silently destroying senior metabolism and causing unexplained weight gain. Thank you for trusting BioVision with the health of the people you love most. Your health is your greatest vision.